Good morning once again, Sam here. I'm going to be doing another Leetcode question. We'll be doing a random easy algorithms question again. I'll have the link below if you'd like to follow along, and let's see what we get. We'll start the timer as well here in the bottom right. I like doing that every so often. Okay, so we got number 1078. Occurrences after Bigram. Given two strings, first and second, consider the occurrences in some text of the form first, second, and third, where second comes immediately after first and third comes immediately after second. Return an array of all the words third for each occurrence of the first, second, third. I have no idea what that means just yet. I'm glad we're reading this together. Also, I'll be doing this kind of mock interview style. I'll be using the code editor here on the left. The goal here isn't for me to just solve the problem as fast as possible. It's more about being a good candidate and showing how you think to the interviewer so that they can give you a high score and you can get accepted to the company. Also, I think it's just good practice. If you can communicate what you're thinking out loud, it makes it a lot easier to work with like coworkers and friends and others when you're building a code base where you're working together with someone else, which I think for the really big and fun projects, that's going to be all of them. Not always, though. It's fun to do your solo ones. Okay, anyhow. I'm trying to not get too distracted. Given two strings, first and second, so let's have a look at our example here. Alice is a good girl. She is a good student. Okay, we're given the first and the second strings, A and good, and it'll output in some text of the form first, second, third. Alice is a, so or A good. So A good, and then the next word is girl, and a good student. Oh, okay, I see. Return an array of all the words third for each occurrence where it's a good girl in this case, or this one, we rock is because we will, is we will, we, and then we will rock. All right, that's kind of cool. How do we want to approach this? There's a couple of ways I can think about this already. I hope this was clear to everyone. So let's have a look at this we will rock you. I think that's a really good example. I'll try this notes right here. So if our input is we will rock you, we know there's two positions for it. And I just want to make this super clear so we're on the same page. So we is one of them, as well as we will rock is another, where it's those three words combined. And the input is that, as well as we, as well as will. So as long as we have the A, B, C, then we return all the C's. We and rock. So some quick questions is our input string always delimiter? Delimiter is space. And the answer is going to be yes for Leetcode, I think. Yep, single space. Don't have to worry about multiple spaces. That's another question. Is our input always alphanumeric? Yes, again in Leetcode. Would we have to worry about any sort of special characters? It shouldn't really matter as long as the delimiter stays to be a single space. Fit in memory? And the answer is yes for Leetcode. Again, in this case, not bigger than 1,000. If it didn't fit in memory, we'd want to do some sort of stream-based approach where you're not keeping the whole string in memory, you're just iterating over the characters and or the tokens. Okay. And also here we know that our inputs of first and second will always be a non-empty string, because that is actually an interesting question. Like, if it was an empty string, does that mean it's only the start of the array? We can only check at the beginning of the input string. Don't have to worry about in this case, but good questions to ask with our interviewer in case that comes up. And the other is that the maximum length of that is 10, so pretty small. So what kind of approaches could we do? Approach one. And can everyone see this? I hope so. Yeah, still good. Okay. So first approach, some sort of brute force, let's say. Brute force, get every triplet of words, compare first, second, third, and keep third if correct. So this would be okay. Every consecutive triplet of words. Let's not make it too crazy. Let's say that W is number of words, and C, I'm talking about for big O at this point. C is number of characters a word. So n here is equal to W times C, total string length, which is what we have here. So comparing every consecutive triplet of words would be 3 times the number of words, which and you're doing a character compare for all 3 of them, 3 times C, 3 times W. We still end up with the O of n time, even if it's pretty inefficient. And space-wise, it's O of 1 space, so that's actually not bad at all. We could do this. We could try to be a little bit smarter. Let's think about some things we want to do first. Let's split up the string into tokens. And then we have O of n space to create this list, which is fine. I think actually, part of me wants to go a little bit smarter, but this is a pretty straightforward, easy question, so I don't want to. And by smarter, what I mean to say is we could do an O of 1 space where we don't keep any of the words themselves. We just iterate over the characters. And so here the idea is approach to iterate over characters, wait for match of first, second, and return third. After, one of the things we need to keep in mind is once we reach the end of this one, we don't want to keep iterating from this point, because otherwise we'll miss the second we will rock you. So what we actually need to do is kind of step back to the second word. Here's a question: will first and second ever be the same? So what happens if we had this input and the both of the words were we and we? So in this case, we'd get an output of empty, I would assume, none. Here, sorry, just keeping that in the right form. But if we had, say, a we and here, we get 1, will. I think that's allowed. I don't see any reason why they are different. It doesn't say that they're different words. So we do need to keep in mind that case. So, and if that's true, here we have 1. And actually, let's just create the worst possible one where we have will is one of them, like that. And see how many we can get out of that. It's good to do these kind of test cases. So we have we and we. So the first one will be right there. The second one will be right there. So we get 2 outputs of we and will. And then the third one, we will, does not apply in this case. So we need to step back to the second word, or the first word, as not this one, but the next one, when we're going through our iteration. Let's do this. Let's not overcomplicate this. Let's split up the string into bits, and let's just start coding and seeing how we do. Some other options we have here is approach 3, build a hash map of triplets of words, return all triplets starting with first, second, and get the thirds. We can already skip any triplet that's not right. I think that's a valid option. We can just kind of iterate through the list. So let's try it. Approach 1 brute. We'll create our words equals text.split. We'll split it with that delimiter. This is O of n space, O of n time as well, actually, to iterate through all the characters inside of there. And then for I in range, length of words, -1, 2, 3, I think. So -2. We don't want the last, we want to go 0, 1, 2, 3, 4, 5, 6, 7, 9, and there's 9, -2. Yeah. So here, oh, we have to close, no, we've closed the array. Triplet equals words from I to I plus 3. And if triplet 0 equals first, and this is kind of our super brute force approach, and we can try to optimize it right after. And triplet of 1 equals second. Return, or let's see, our output equals an empty list. Output dot append triplet dot third, and then we just return output. So this is basically just iterating straight over the list. We're doing this O of W for the number of words. This comparisons are O of C. Building this array is going to be O of N in the end, because we're in the worst case getting every possible triplets possible. Let's just imagine a string of A's and the inputs are first and second are A's. Yeah, okay, so O of W times O of C equals O of N again. So we have our final output of O of N time, O of N space. I think space is something we can improve on. Time, not that much, I don't think. What happens if our text doesn't have enough words in it? So let's say the length of words is 2. 2 minus 2 is 0. We shouldn't iterate over that. Length of words is 0 or 1. We shouldn't iterate over it because it'll be ranging to a negative, which will just empty out. So we just return the output, which is empty. I think that should work. Let's have a go with the test case. All right, passes these 2 test cases. And let's try submitting and seeing if we have any missing issues here. Yep, it passes, seems fine. Well within the main area. Always happy to see a nice quick pass, but what could we do now? I'd like to think about maybe, is there a way we could turn this into O of 1 space? And I think the answer is yes, because you don't have to split up the text, and I don't want to do that, because, I mean, in this case, it's totally valid, especially for such a small toy problem like this. I wouldn't want to waste too much dev time on coming up with a different solution, but I'd like to tokenize or iterate O of 1 space. So one of the ways you could do this, this would be O of N times C, I think. Let's just brute iterate. I want to kind of just talk it out with you all. We don't split the words anymore. We are going to use the original string text now. And we're going to use O of C space for where C is chars in a word. And the idea is char word equals empty. Actually, you don't even need to use that, because you can return it back at the end of the array. Our output, actually, no matter what, our output's going to be, in the worst case, O of N. So, because we might return the full text input as a new in the worst case. So technically, we're going to never be better than O of N space, unfortunately. But we don't have to store O of N if we do this brute iteration approach. It doesn't make it as exciting to do. What I'm trying to say out loud here, actually, what I'm trying to do here is we're going to do for IC in enumerate text, we're going to iterate over characters, check that characters so far have matched with goal is equal to first plus, let's see, first, second, that's our goal string. Basically, what we'd like to do is check if we're iterating through a goal pointer. And once we hit the end of the goal, that means the next word is valid. We return that word. And then we step back a word or two. This would become pretty complicated. It would save us a little bit of extra space by not splitting up the array first. I realize for a question like this, this isn't actually relevant to implement. I think it's just good to be able to talk it out with your interviewer. So we'll skip that. I'm trying to think of any smarter tokenizing, like what I'd like to do is some sort of streaming tokenizing approach. If you can think of something in the comments that's better than this brute force implementation, please let me know. I'd love to hear it. One of the things we might check here is that you don't actually have to do checks of every single triplet. If you know that they're bad, you can skip to the next third step in the word or something, and that'd be O of W divided by 3. There's some like minor optimizations there. Yeah, I think honestly, this is probably a good stopping point for this question. Hopefully this was interesting for you all, and I'll see you all for the next video. Let me know if you have anything interesting to say about this question. I'd love to hear it. Anyhow, thanks and see you all next time.